we're going to solve some quadratic inequalities today, which since instead of being straight lines, quadratics kind of have this U shape, they're going to have, instead of a entire half of the number line as solutions, they're going to have different pieces of it. So that probably didn't make any sense. Let me draw a picture. Say you have x squared plus 2x is greater than 0. A quadratic makes a lovely little parabola shape, so say it's like that. And then this inequality is asking for places where its output's greater than 0. So where it crosses the x-axis is where it's equal to 0 at. We want to know the regions where it is greater than 0, which that would be the part that is above my x-axis. So there's actually two sets of x values where my output's greater than 0. In the middle, in between there, those x values give me outputs that are less than 0, so that is not part of my solution set. So depending on whether your parabola opens up or down, you're going to have either two intervals of solutions that work or just one. So how we're going to solve this is we're going to first just set my quadratic equation equal to 0 that corresponds to my inequality and figure out where it crosses the x-axis at. So if I factor this one, I'm going to get x equals 4 and negative 3. Now, if I don't want to actually sketch a graph of this, I can just plug values in and test it. So basically, we've got three regions of my number line. I know it crosses at negative 3 and 4, and I want to know which of those intervals it's going to be less than 0 on. So we're going to test a number in each. So let's test a value that's less than negative 3. Any number you want. I'm going to do negative 4. So if I plug negative 4 in, I could plug it into my factored version. Sometimes I prefer to do that, or my original. I'm going to plug it into my factored version this time. Okay, so if I plug that in, I'll have negative 8 times negative 1. This is a checking to see if it's less than 0. 8 is not less than 0. So if you look at your original inequality, I wanted to see if that result was less than 0. It is not. So that means x values less than negative 3 do not work. Let's test a number in the middle. So I'm going to do 0 because 0 is my favorite number to plug in and test. So if I plug 0 in, I'm going to actually plug it into the original. You can use whichever. Looks easy to plug in the original. I get negative 12. Negative 12 is less than 0. So the numbers in between negative 3 and 4 will work. And then if you test a value that is greater than 4, let's go with 5. I'm going to plug it back into the factored version again. I'm going to end up with positive 8. And again, positive 8 is not less than 0. Which, if you think about the graph, we know that only if the middle works, the outer two shouldn't. Check to see if you should include negative 3 and 4 or not. So this is strictly less than, so I'm not going to include my values where it touches and is equal to 0. So let's go ahead and look at another one. If you don't already have 0 on one side of your inequality, you're going to want to get it there and then solve your corresponding equation. I'm going to figure out my two numbers that multiply to negative 24 and add to 5 here because there's a lot of factors of 12. I don't really want to guess and check. Let's see. That would be positive 8 and negative 3. And then I can rewrite my middle term as 8x minus 3x and factor out a common factor from a couple of groups here. I can factor out a 2x, which leaves me with x plus 4. And a negative 3, which leaves me with x plus 4 as well. So my factored version is going to be x plus 4 times 2x minus 3. If I set each of those factors equal to 0, I'll have x equals negative 4, and then x equals 3 over 2 as my places where my equation's equal to 0. Well, not really looking for where it's equal to 0, but those will help us figure out my intervals that do work. So if I draw myself a number line here and break this into intervals of potential solutions, we need to test a few values here. I'm going to go back to my original and plug -5 in. That's going to give me 2 times 25, 50 minus 25 is 25, and 25 is greater than or equal to 12, so that does work. If I test a value in the middle, I'm going to go with 0 because it's in between -4 and 3/2, and it's my favorite. So if I plug in 0, I'll have 2 times 0 squared plus 5 times 0, it's 0. Is 0 greater than or equal to 12? No, it is not. So values in between -4 and 3/2 do not work. And then for my last value that I'm testing, I'm going to go with something bigger than 1.5, so let's go with 2. If I plug 2 back into my original, 2 times 2 squared plus 5 times 2, seeing if it's greater than or equal to 12 or not. Yep, it is, because it's 18, and 18 is greater than or equal to 12. So those do work, which means that my intervals where my x values are less than or equal to -4 and greater than or equal to 3/2 work, because it's an or equal to, we want to make sure we include my endpoints. So join them together with a union, and there is your solution. We have talked about quadratics representing projectiles before. So we've got this function that gives us the height of a cannonball, and we want to see when our cannonball is more than 80 feet above the ground. So let's take my height equation and say I want to know when that is greater than 80. Get 0 on one side, and then just like we've been doing, solve the corresponding quadratic equation, plug some values in and test. I'm going to factor out a common factor of -16 first, which is going to flip all my signs and make things easier to work with. If it didn't factor, you'd have to maybe do quadratic formula. It would still be fine. So that'd be, let me think, -5 and -1. So t equals 5 and t equals 1. I could plug values in and test, but if you kind of think about my situation, I'm launching my cannonball up in the air. I want to know when it's more than 80 feet above the ground. Well, it's going to be more than 80 feet above the ground in the middle of its path, so between 1 and 5 seconds. So instead of plugging values in, I'm going to just use my brain and say, hey, it's going to be between 1 and 5 seconds, not less than 1 second or more than 5. Another note as well, if you get like imaginary numbers or something, that means your cannonball or your projectile is never going to reach that height. It doesn't fly that high.